This is the card coin cup lab. First thing I'm going to do is I'm going to sanitize my hands just to make sure there are no germs on my hand. Then I'm going to bring the camera forward so you can see what we're looking at. All right, there we go. All right, so you can do this experiment at home because all you need for this experiment is you need a playing card. Got the ace of spades right here, sturdy cup. I have a small beaker here just so we can show you that, but it needs to be like a sturdy cup, like a plastic cup. It'll work, but it won't work so well. And I have a nickel, a penny, and a quarter. So what the direction says is place the card on top of the cup. So I'm going to try to make it nice and level there. And place the nickel, right? We're going to start with the nickel. Place it on top of that card. Now, flick the card with your finger horizontally. What happened to the coin when you flick that card? Explain why you observe this. Use the word inertia. So I'm just going to flick the card horizontally like this, and we're going to see what happens to the coin. Well, that was pretty fast, but notice that it went into the cup. Let's do that again. Right, I'll place that right there. So why is it? Why did this happen? Now, what I want you to think is the hint that I gave you is what are you applying the force to when you're flicking that card? What aren't you applying the force to when you're flicking that card? Right? So remember, both of these objects have inertia. They have the tendency to continue doing what they were doing. Right? So this coin sitting on top at rest, it has the tendency to continue to be at rest. When I flick the card, we'll think about what am I applying the force to and what am I not applying the force to. So then it says we'll draw the free body diagram for each of the scenarios. So the first scenario that we have is it's just sitting on top of the card. Well, I know I have gravity and I have a normal force pointing up. Now, right now, there's no force, that is no other force other than gravity that is acting on this coin. Well, then the next one says, the scenario is the coin is on the card as the card is moving. So it says ignore friction. Now, yes, we're going to have a small kinetic frictional force because that card will be sliding out. But I want you to think that as I'm flicking this card, if I'm ignoring that small frictional force, well, what forces are being applied to that nickel as this card is sliding, right? So I flick this card and the card is going to be moving. Well, what forces are going to be applied to that nickel? Right? And then the last scenario says, well, what forces are being applied to this nickel once that card is already flicked and now it's in air and it's about to fall? What force or forces are being applied? And draw the free body diagram for that. So that's what I want you to think. Now, the conclusion here, it says repeat the experiment with the penny, then the quarter. Which, if any, was easier than the nickel to get in the cup? Which, if any, was harder than the nickel to get into the cup? Explain your answers. Use the word inertia. And so I'm going to try it with the penny. Put the penny on top. I'm going to flick the card. Oh, it went into the cup. Now I'm going to try it again with quarter. I'm going to flick the flick the card. Oh, notice that it went into the cup. Right. I want you to think about those scenarios and compare it to the nickel. What are you applying the force to when you're flicking that card? And what aren't you applying that force to when you're flicking the card, right? Both of these objects have inertia. They want to continue doing, they have the tendency to do what they were already doing. So that is the card coin cup lab. Last thing I'm going to do, I'm just going to put some hand sanitizer on before heading back and touching anything else.